Okay, we have one more mini lecture for this week, which is going to finish off the portion of Chapter 3 that we are responsible for learning in this first week of class. So let's go ahead. This one should be a short one, I hope. Oops. Okay, so we left off before with naming open chain structures of alkanes. And now we're going to finish up with cycloalkanes. And then we're also going to finish up with trying to tie in nomenclature with other functional groups that we've become familiar with at the end of Chapter 1. So here, again, is how I name cycloalkanes. If there is only one substituent, like in these examples here on this slide, I'm going to name the cyclic structure, and then I don't need a number. I'm just going to name the substituent. So here I have isopropyl cyclopropane. Here I would have methyl cyclobutane. And here, this is that tert-butyl group, and it's attached to a cyclopentane, so that would be called tert-butyl cyclopentane. If I have more than one substituent, I do have to consider the correct way of numbering. So what I'm going to do here is look at this compound. This actually illustrates a couple of things. If I start numbering, I could have 1, 2, 3, 4. I could have 1, 2, 3, 4. Here I would have a 1 and a 3 substituent. Here I would have a 1 and a 4 substituent, so I know it's not this one. Here I have a 1 and a 3 substituent as well. So why do I pick this one? It's because the substituents are ethyl, which is this 2-carbon chain, and methyl. When I have a tie here, remember I would go with the alphabetical order. So E is lower in the alphabet than M, so I'm going to use this numbering system where my ethyl gets number 1. So this is the correct name, 1-ethyl-3-methyl cyclopentane. Here's another example. Now here, I have different ways to number. What if I started with the bromine and I go to this direction because that's where I'm going to encounter my substituent first? I would have 1, 2, 3, 4. So I would have 1, 3, 4 for my substituents. However, if I start here and I go this way to encounter that first substituent with a lower number, I would have a 1, 2, 4. This numbering system is better. Once I number it, I'm still going to arrange those substituents in alphabetical order. So I'd have 4-bromo, 2-ethyl, and then -1-methyl. It's got a 6-membered ring, so that would be cyclohexane. So you always want to consider your numbering in these situations. As we mentioned before, I could use cycloalkanes as a substituent in my naming system as well. When a single ring system is attached to a single chain, and that chain has a greater number of carbon atoms, this is going to be the substituent. Here I have 1, 2, 3, 4, 5 carbons. So that will be a pentane derivative. On number 1, on the first carbon, I have a cyclobutyl. Now notice I need the 1 here because that's referring to the number on the carbon of the pentane chain that I actually am connecting to the cycle. If I have more than 1 ring system, I could use this di prefix. So here I have 1, 2, 3. Naming this as a propane derivative is going to be a lot simpler than trying to name one of these groups attached to a cyclohexane. So I'm just going to call this 1,3-di-cyclohexyl propane. This website is a really good website that illustrates many, many things about the nomenclature, the IUPAC nomenclature system that we have talked about in this part of the chapter. This is much more comprehensive than the book or anything that I really go into, but it's a really great reference if you get stuck and you don't understand why your name isn't the right name, or if you get something that's more complicated and you don't really know what to do. So make sure you sort of check this out just to see what's going on if you need another additional resource. So we're going to expand our nomenclature a little bit and look about what happens when I want to incorporate other functional groups. My IUP nomenclature kind of has a 3-part system. The prefix is going to be the number of carbon atoms in the parent. The infix tells us the nature of the carbon-carbon bonds. I'm going to have an AN, an EN, or a YN if it's an alkane. This would be alkanes where I only have single bonds. This would be alkenes. EN where I have 1 or more double bonds, and this are alkynes, the YN, where I have 1 or more triple bonds. So keep in mind that this infix is the nature of the carbon-carbon bonds in the parent chain. Now this is another important part. The suffix tells us the class of the compound. So if I just have an E, that's going to be a hydrocarbon. So again, that's going to be the alkane, the alkene, or the alkyne, depending on if I have an AN, an EN, or a YN. If I have an all ending, that's an alcohol, which remember has that OH. If I have an al, that's an aldehyde, which means I have this aldehyde functionality. One is a ketone. Remember, my ketone has a carbonyl connected to 2 carbons. And then if I have oic acid, that's going to be my carboxylic acid. And these suffixes actually will indicate which class of compound that this molecule is going to belong to. Here are some examples. Here I have 1, 2, 3 carbons. That's where I get the prop. This is my double bond. And then this is my alkene. So this would be called propene. Here I have 1, 2. That gives me the F. This means it's all carbon single bonds. And then the all means I have the alcohol. This guy here, 1, 2, 3, 4. This has 4 carbons. Again, they're all single bonds, but this is my ketone, which is really right here. If I look at this guy, 1, 2, 3, 4, I have 4 carbons, all singly bonded. This is my aldehyde. So that's this group right here. So that would be called a butanal. 1, 2, 3, 4. I still have 4 carbons, so I still have bute. These are still singly bonded. And then here is my carboxylic acid. So this would be a butanoic acid. Here I have a cyclic structure. Cyclohex is my cyclic structure with 6 carbons. They're all single bonds. And this is my alcohol, which is right there. This guy is got F because it has 2 carbons. This is because it has a triple bond, and this would be an alkyne. So 2 carbon alkyne is ethine. And then here I have an amine, right? When I have nitrogen attached to either hydrogens or other alkyl groups, that's an amine. I have 2 carbons, so it's an F. Those carbons are singly bonded, so I have F and amine, which is the name for that particular compound. So this gives us a guide to how we're going to incorporate functional groups into our naming. There's a priority system. Carbon-carbon and carbon-hydrogen bonds are very low in the priority. An alcohol has a higher priority. Aldehydes and ketones have a higher priority. The highest priority is going to be a carboxylic acid. So when I have more than one functional group, we get into a little bit more complicated systems, and we're going to talk about that later. But this is the basic part you have to know. This is an idea of how I can take some simple molecules that are basically based on alkanes or alkenes or alkynes, and then name them and incorporate other common functional groups like alcohols and amines into the overall name. So this whole naming thing takes a lot of practice. Practice, practice, practice. This is what you need to succeed in this class. The more problems you do, the better off you'll be, the more you find that you'll understand things. As always, ask me if you have any questions. One more thing before we go. Remember in those butyl groups, I called the sec butyl was attached, that group was attached to what I call the secondary carbon. So I just want to talk about how we classify carbons based on what is attached to that carbon. A primary carbon is a carbon that is bonded only to one other carbon. So if I look at this is bonded to 1 carbon and 3 hydrogen, so it's a primary. This is bonded to 1 carbon and 3 hydrogens, so it's primary. This is bonded to 1 carbon and 3 hydrogens, so it's primary. This is primary, this is primary. Let's look at secondary. A carbon bonded to 2 other carbons. Well, look at this guy. I have my first carbon, my second carbon, 2 other hydrogens. That would be secondary. Tertiary. A carbon bonded to 3 other carbons. Tertiary is here. I'm going to use a different color. If I look at this carbon, I have 1 carbon, 2 carbon, 3 carbon. So that would be a tertiary carbon. And then quaternary, a carbon bonded to 4 other carbons. I'll use another color. If I look at this, I have 1 carbon, 2 carbon, 3 carbon, 4 carbon. So this is a tertiary carbon. So let's think about what that meant when we were talking about those groups, right? If my attachment is right here to my parent, and I have 1, 2, 3, 4. Remember, this is just a butyl group. If my attachment is here, well, now this carbon, this was my sec butyl, because this carbon is a secondary carbon that it's attached to. Let's look at this. Here's a carbon. It's attached to 2 other carbons. This is a secondary carbon. So that's where I get the sec part. Iso, remember, was just where I have my whale tail. So this is 1, 2, 3, 4, and this is where it's connected, and I have my whale tail. So this is isobutyl. And then recognize if I have something attached and I have 3 other carbons, this carbon is the tertiary carbon. So this is my tert-butyl group. So when I look at it, I have a carbon attached to 1, 2, 3 other carbons. That's where I get the tert part of the name. So organic naming is actually really logical once you understand how everything works. It takes a while to get comfortable with it. You're going to look at alkanes and you're probably pulling your hair out going, oh my gosh, oh my gosh, oh my gosh. At the end of the class, this is going to be like so second nature that you're not even going to realize that you ever struggled with it. But you do have to actually take the time to really master this. So with that said, we are finished for this week's lectures on chapter 3, which is only partially way done with chapter 3. Next week, we're going to continue chapter 3 and move on also to chapter 4. So I will see you guys soon. Study hard, do a lot of problems. Let me know if you need help. Bye-bye.